today?
Today we're discussing the article titled Adaptable Logical Control for Large Language Models.
So, large language models have been doing great in tasks like translation and summarization, but controlling them with logical constraints is still tricky. This paper introduces a new framework called Control-G to tackle that issue. Mira, could you tell us more about the main problem this paper addresses and what contributions it makes?
Sure, Jensen. The paper focuses on the challenge of fine-grained control of LLMs to follow logical constraints, which has been difficult despite advances in fine-tuning techniques. It introduces Control-G, a framework designed to provide scalable and adaptable control over LLMs by using a combination of hidden Markov models and deterministic finite automata.
All right, let's dive into the preliminaries. What are the key concepts introduced here?
Well, this section lays out the probabilistic formulation for logically constrained generation from LLMs and reviews prior work. It also explains hidden Markov models, which are used as approximations of LLMs in the Control-G framework.
Got it. So how does constrained generation with logical constraints work in this context?
Oh, interesting question. The idea is to generate token sequences bounded by a number n given a logical constraint. The challenge is computing the marginal probability while ensuring the sequence satisfies the constraint.
And what about the prior work? How does it compare to what's being proposed here?
Right. Previous methods like neurologic decoding and GD use heuristic searches or auxiliary classifiers but don't guarantee constraint satisfaction. Control-G aims to overcome these limitations by providing a more reliable approach.
That sounds promising. It's always good to see improvements in reliability. Let's move on to the Control-G pipeline. Can you explain how it works?
Absolutely. The Control-G pipeline involves 3 steps: distillation of an HMM, constraint specification using DFAs, and inference by conditioning the HMM on the DFA-specified constraint. This allows for efficient autoregressive generation from the LLM.
Interesting. How do logical constraints get represented as DFAs?
Oh, that's a neat part. DFAs are computational models that accept or reject strings based on logical constraints. They consist of states, symbols, and transition functions, making them efficient for representing constraints.
And what about the algorithm for marginalizing HMMs over DFAs? How does that work?
Great question. The algorithm uses recurrence relations and the forward algorithm to compute probabilities efficiently, leveraging the Markov properties of both HMMs and DFAs.
That's quite clever. It seems like a robust way to handle constraints. Now, let's talk about constructing DFAs for constrained generation. What does this involve?
Well, this section explores using Control-G on benchmarks like common sense generation and text infilling. It focuses on creating compact DFAs to represent logical constraints effectively.
How does Control-G perform on the Common Gen benchmark?
Oh, it performs really well. Control-G achieves high constraint satisfaction and outperforms baselines in various metrics like blue and rouge scores.
And what about the text infilling task? How does Control-G handle that?
Yeah, for text infilling, Control-G constructs DFAs for each fragment and concatenates them to maintain order. It shows strong generalizability across different masking ratios.
Impressive. It seems like Control-G is quite versatile in handling different tasks. Moving on to scaling up Control-G, how does it extend to interactive text editing?
Well, the paper discusses extending the co-author system to allow users to control LLM-generated suggestions. Control-G is applied with the TULU-7B model and compared against GPT-3.5 and GPT-4.
What were the results of these experiments?
Oh, the results were quite revealing. While GPT-4 excels in quality, Control-G consistently satisfies constraints and achieves higher overall satisfaction rates.
And how about the runtime analysis? Any insights there?
Yes, the runtime analysis shows linear scaling with DFA size and constant extra computation cost introduced by Control-G, which is quite efficient.
That's good to know. Efficiency is always a plus when scaling up. Finally, let's discuss the perspectives on improving LLM reasoning abilities. What potential applications does Control-G have?
Well, Control-G can be used beyond traditional tasks, like enhancing reasoning in grade school math problems, or even detoxifying language models by avoiding certain words.
How did Control-G perform in the case study with the TULU-7B model?
Oh, it was quite effective. By integrating Control-G, the model's accuracy improved significantly, showing its potential in enhancing reasoning processes.
That's encouraging. It seems like Control-G has a lot of potential for future applications.
Thanks for tuning in, everyone. Until next time.
Goodbye, and remember, if you want to listen to the full version of the article, just forward the email with the article to full@lettercast.ai. See you next time.